Hello, my friends, and welcome back for the last lesson in this course. We are in the probability module. We have looked at a lot of things here. I am scrolling over, turning the pages to compound probability. And I'm going to zoom in. I will probably do this in two separate videos just so they're not so terribly long. And the first thing I need to tell you is the definition of independent events. And I would ask you to think about the word independent. What does it mean when someone or something is independent? It means that that person or thing does not rely on another person or thing. They stand alone. So an independent event in mathematics is a second event that does not depend on a first event. And you might be thinking, I would be. But let me do these two examples and hopefully you'll see the difference. So this first example is an independent probability. And compound just means that we have more than one event that's occurring here. If you roll the die 3 times, what is the probability of rolling a 3, a 5, and any even number in any order? Now don't panic on me. Let's break this down. We want to get a 3. We want to get a 5. And we want to get any even number. And the order doesn't matter. That's a really good thing because I don't have to roll the 3 first. I could roll the even number first. It doesn't matter. We're just looking at the probability of these 3 events that do not depend on each other. We don't care which one comes first. So what I want to do is take them one at a time. And I'm going to zoom in here so we're just focused on what we need to see. We want to get the probability of a 3 and the probability of a 5 and the probability of any even number. So we want these 3 things, and it doesn't matter the order. So there's that one. I'm pulling these directly from my problem. Even the word and is in my problem. Let me highlight it too. Let's just go ahead and go all out. So you see that I'm just pulling these pieces from the problem and setting them up in a math problem. So to do the first one, what is the probability that I would get a 3? I'm not even going to go there. Let's do it this way. Well, there are 6 sides on this die, so the bottom number is going to be a 6 for each one of these. Because that's the total. Of those 6 sides, there's one of them that's a 3. Let me highlight it. Here's the 3. How many 5s are there? Well, there's just one, 5. How many evens are there? Well, 2 is even. 4 is even. 6 is even. So there are 3 of those. 2, 4, 6, that's 3 possible sides. And you remember what to do when you see the word and. You multiply. And just for the record, if you see the word or, O-R, you would add. But ands are multiplying. So we're going to put this into our calculator. We're just going to say 1/6 times 1/6 times 3/6. I cannot say that word. I'm sorry. I never could. So I end up with, I have no idea. That's not what, okay, here we go. So 1/6 times another 6 times 3/6 is 1/72. So that's your probability as a fraction. Or 1 divided by 72 is 0.0138888 and a bunch of repeating 8s. So if you move that decimal 2 places, it is about 1.4%. I wouldn't bet on that. That's almost 0. But you could even say about 1%. That's probably a better way to round it. Just get rid of the decimal altogether. So it's about 1%. And remember, on our continuum, where 0 is impossible and 1 is a sure thing, we're talking about right there. So I would not bet on this event. If someone said, I'll bet you $1 million, I would say no way, because that is a very unlikely event. Okay, I'm going to stop the video and then I'll come back and show you how to do dependent probability and we'll be finished.